Hey guys, it's Mrs. Stevenson, and we're talking about sequences and series today because it is very important that you remember your terms and your formulas. I have seen sequences and series come up a lot in the Math is Cool tests. So if you haven't already, you should have printed this file out. It's posted right next to where the video is posted. And what I want you to do is, as we go through it, is I will write stuff, on the sheet, and you should be writing stuff down as well. That's what it's for you to take notes, okay? Because I always find that if you write something down, you're going to be much more likely to remember it. And then plus, when you're doing the problems at the end, you will have your notes to refer back to. So again, it is imperative that you remember the definitions and the formulas. So let's just start with a quick review of arithmetic series. For example, something like this, 2, 5, 8, 11. I always like to start working on a series or sequence by listing them out in order. So the term numbers 1, 2, 3, 4, then the associated terms are 2, 5, 8, and 11. And of course, this is a very easy series. We can see that the common difference between each two terms is just 3. Okay? So that is equal to D. And again, that's called the common difference. Okay, so then we can use that to define the general term, which is referred to as A sub n, as A sub 1, that's the first term, plus n minus 1 times D. All right, so in other words, every other term just equals the first term plus, n minus 1, 1 less, d's added to it. Okay? Okay, and the other thing that is really important to know is how to calculate the partial sums, or in other words, the sum of the first n terms. All right, so the nth partial sum is just equal to n, which term number, how far are you going, and then just plus the average of the first term and the nth term. All right, so if you just remember that it's just the average of the first and last term times the number, that is also fairly easy to remember. Okay. All right, I'm going to erase this so I can scooch down on the page. And also a very quick review, of geometric series. All right, so here's an example of a geometric series. Again, a very simple one. 2, 6, 18, 54. Again, I'm just going to start by writing it in a column form. For me, if it is a more complicated series that you're trying to figure out the pattern, it's just easier for me to look at it this way. Okay, so in this case, we can see that between every two terms, we are just multiplying by 3, and so on. Okay, so in this case, 3 is r, lowercase r, or in other words, the common ratio. So we use that r to define the general term of a geometric series. So a sub n is just equal to, again, the first term, and then times that common ratio raised to the n minus 1. So, first term and then just one less r's. So you just keep multiplying by r. The partial sums, you can calculate this of a geometric series. I haven't seen this one used as often, but it doesn't hurt to know it. So the partial sum formula is a sub 1 times 1 minus r to the n over 1 minus r. Okay, I've seen that one come up maybe once or twice, not as often. All right, I'm going to erase and go on to the next page. Just one more topic quickly on geometric series. Okay, so here's a different geometric series. So my first term is 2. My second term is 2/3. My third term is 2/9. So this time you can see that the common ratio every time we are multiplying by 1/3 to get to the next term. So in other words, the absolute value of our common ratio r is less than 1. Okay? And when that is the case, then you can calculate the infinite sum of all of the terms in the infinite series. Okay? And this formula is definitely a must know. So the infinite sum is simply equal to the first term, a sub 1, divided by 1 minus r. Okay? So if you compare this formula to the one on the previous page, you can see similarities. They both have that 1 minus r in the denominator. They both have an a1. The only difference is that the partial sum then has that additional term, the 1 minus r to the n. All right, so now what I really wanted to show you on the next page, I'm going to erase this again, is in working through a lot of these tests, I have seen this very interesting technique used. I'm calling it a new technique, I guess, because it's new to me. So I've seen it enough times that I thought it was worth showing it to you, and plus it's pretty cool. So let's look at this problem, which is to evaluate the sum of this infinite series. 8 over 1 plus 7 over 2 plus 6 over 4, etc. Okay, so let's start just by listing it down. Okay, so the first term is 8 over 1, and there's a reason the stuff is written like this, so let's just leave it. The second term is 7 over 2. The third term is 6 over 4. Fourth term is 5 over 8, and so on. Okay, so if we just start by looking at it to try to figure out what kind of a series it is, well, you can see the numerators, 8, minus 1 is 7, minus 1 is 6, minus 1 is 5. Okay, so the numerators kind of look like they're arithmetic. The denominators, 1, 2, 4, 8, well, those are obviously powers of 2, so the denominators are geometric, but then put them together and they're neither. Okay, so it's neither an arithmetic or a geometric sequence. So in other words, we need to use some different technique. Okay. All right, now what I need to do here is I'm going to just write this out again. So S, we're going to call the sum of the whole thing S. And that's what we want to find. Okay, so it equals 8 over 1 plus 7 over 2 plus 6 over 4 plus 5 over 8 and so on. Okay. All right, so here is the technique. We are going to multiply the entire thing by 2. Okay, so obviously that means, multiplying both sides, because we've got an equation here, by 2. So on this side, I'm just going to have 2s, and then I'm going to show you how I'm going to multiply by 2 over here. So first, let me just do this again, and then I'll come back and add in my multiplications. Okay, so just go ahead and write this down again. Leave a little space in between your terms, because we're going to go back and pencil something else in. Okay. All right, so I'm going to multiply each term by 2. Just like that. Okay. Now, when I do this one, this first one, all right, I'm just going to go ahead and multiply that. It's just 8 times 2 is 16. Okay. All right, when I do this one, I'm going to cancel the factor of 2 with the denominator. All right, so that one just equals 7. All right, when I do this one, I am going to cancel just this factor of 2, which is going to leave me a 2 in the denominator. So that becomes 6 halves. And same thing here, I'm going to cancel a factor of 2 with the denominator. So that becomes plus 5/4. Okay. And then I tell you what, let's add in one more term up here just so we can see the pattern more clearly. Let's add in, the next term up here would have been 4 over 16. Okay. So let's just go ahead and add that in. So I want to multiply that by 2. And then, of course, we have all the rest of the terms that we're not going to write out. So I'm going to cancel this factor of 2. So we're going to end up with 4 over 8. All right. So again, this now equals 2s. Okay. Now, the technique is here, we are now going to subtract the original sequence s. All right. So I'm going to write the original sequence s beneath here, and then we're going to subtract it. Okay. Now we want to get the denominators of this sequence to line up with the denominators of this sequence. Okay. So in other words, my 7 halves term is going to go here. Oops. So first we've just got 8. We can just write it as plain old 8 now. And then we had plus 7 halves. Kind of work that in, okay? And then plus 6/4. And then plus 5/8. And so on. All right, so when we subtract these, 2s minus s leaves us with s. And that's what we're trying to find. What is the sum of s? All right, so up here I have 16 plus 7. Okay, I'm going to subtract the 8, so that leaves 15. And then plus. Okay, 6 halves minus 7 halves is minus 1/2. So actually I'm going to change this to a minus sign. So minus 1/2. 5/4 minus 6/4 is, okay, so that's minus 1/4. 4/8 minus 5/8, well, that's minus 1/8. Okay. All right. So did you see what just happened there? because what we have now is, well, just this constant out in front, but what we have here now is just a purely geometric series. And we can make it even easier by saying, well, let's just do this. 15 minus paren 1/2 plus 1/4 plus 1/8 plus all the rest of them. Okay? So this right here, if we were to do like this, n(a) sub n, all right, so the first term is 1/2, the second term is 1/4, the third term is 1/8, and so on. So the common ratio is 1/2. And it's less than 1, so therefore I can calculate the infinite sum of that geometric series. Okay, so remember, it's just the first term, a1, which is 1/2, divided by 1 minus r, which is 1/2. So this is super easy because it's just 1/2 divided by 1/2, which is 1. Okay, so in other words, this entire sum is 1. So then the answer we are looking for to what does S equal? Well, it's just 15 minus 1, or in other words, 14. Okay, so that is the answer to the problem right here. All right, so that's it for the lesson. And okay, I'm gonna erase and go on to the next page. So on the last page here are some homework problems for you, and you can do these, and you can let me know if you have any questions. You can turn them in to Mrs. Bird and or Mrs. Adler, and I think they said something about raffle tickets for prizes. You'll have a drawing or something, assuming that you turn this in. And even more raffle tickets if you have turned it in and gotten all the answers right. Okay, so I do just want to give you a hint on this first one. Okay, so this first one is very similar to the example I just did. You want to use that new technique. And if you remember in the problem we just did, we started by multiplying S by 2. And that was because the denominators of the terms were powers of 2. So obviously you'll see in this problem the denominators are powers of 3. So just a hint, you want to start by multiplying the whole series by 3. Okay, and the rest of the problems are just some typical types of math is cool sequence problems, okay, where you'll want to use the definitions and formulas that we went over on the first couple of pages. All right, I'll see you guys next week. Bye.